Hi friends, you are welcome back to another interesting question. We are asked to calculate the area of the circles, that is, these circles. This quadrilateral is a square-shaped quadrilateral. We have the length of this line segment to be 18 units. That of this is 10 units, and this is 2 units. So how can we solve this? How can we calculate the sum area of these two circles? Well, it is very simple. Like we all know, formula for calculating the area of a circle is pi r squared, where r is representing the radius of the circle. But here we have two distinct circles. They'll have their individual radii. We assume the radius of this circle to be a and that of this to be b. The area of this circle is pi a squared and that of this circle is pi b squared. Therefore, the sum area is pi a squared plus pi b squared. Here we factor out pi, so it is pi into bracket a squared plus b squared. Pi is a constant. We need the values of a and b. We start by labeling the necessary point P, Q, R, S, T, V, W, A, B, C, and D. Okay, this is a very simple question. We see here line CR is a tangent to this circle at this point. It meets this line CD, which is also a tangent of the circle at this point. We can say they were drawn to the circle from the same external point. And from the circle theory, there is a rule that when two tangents are drawn to a circle from the same external point, their segments are equal. That is, this segment AC and this DC are congruent. So since this is 18, this must also be 18. Here we see this line PT is also a tangent to this circle at this point, and it meets this tangent at this point. So based on this rule, this segment and this are equal. If we let this be C, this must also be C. This tangent also meets this at this point. So since this segment has its length to be the sum of this 10 and this 2, which is 12, this must also be 12. Line PT is also a tangent to this small circle at this point, and this is also a tangent to it at this point. They meet here. So since this is 2 units in length, this must also be 2 units. We look at this triangle CPR. Because of this right angle, it is a right angle triangle. We can use a Pythagorean theorem, which states that the square of the length of the hypotenuse of a right angle triangle is equal to the sum of the squares of the length of the two other sides. The hypotenuse is the side facing the right angle, which is this here. So based on that, 2 plus 10 plus 18 all squared equal to 12 plus c all squared plus 18 plus c all squared. 2 plus 10 plus 18 is 30. 30 squared is 900. 12 plus c all squared is 12 plus c times 12 plus c, which is 12 times 12 plus c times 12 plus c. 12 times 12 plus c is 144 plus 12, and c times 12 plus c is 12c plus c squared. 12 plus 12 is 24c. So it is 144 plus 24c plus c squared. Expand this also. It is 324 plus 36c plus c squared. C squared plus c squared is 2c squared. 24c plus 36c is 60c. 144 plus 324 is 468. Take this 900 to the left. 468 minus 900 is minus 432. So it is 2c squared plus 60c minus 432 equal to 0. Divide through by 2. Here 2 cancels 2. 60c over 2 is 30c, while here minus 432 all over 2 is 216. So c squared plus 30c minus 216 equal to 0. This is a quadratic equation. We can solve by factorization. This 30c can be written as 36c minus 6c. Here c squared plus 36c, we factor out c. So it is c into bracket c plus 36. And here minus 6c minus 216. If we factor out minus 6, it is minus 6 into bracket c plus 36. Here we see c plus 36 is common. We factor it out. So it is c plus 36 times c minus 6, which equal to 0. That is c plus 36 equal to 0 or c minus 6 equal to 0. Make c the subject. So c equal to minus 36 or c equal to 6. C is the length of this line segment. It cannot be negative. Therefore, this can't be the length. So c equal to 6. That is, this segment and this are 6 units in length each. Now from the cycle theory, there is a rule that the tangent of a cycle is perpendicular to its radius through point of contacts. So since this side, this and this are tangent to this cycle at this point, this and this, if we draw the radius of the cycle to each point of contact, the angle formed will be right. Look at this quadrilateral. 3 of its angles are right angles. It is either a square or a rectangle. In both, opposite sides are congruent. That is, this side and this are equal. So since this is 6 and this is b equal to 6, substitute it here. 6 squared is 36. Come back here. This line is a tangent and this is also a tangent to the cycle. So if we draw the radii to the point of contacts, the angles will be right. We look at this quadrilateral. Since 3 angles are right, opposite sides are congruent. Therefore, since this is A, this must also be A. Come back to this side. Its length is x, but it is divided into this 6 and this 18. So x equal to 6 plus 18, which is 24. That is, this is also 24. From line PT, if we subtract this 6, this 12, and this 2, we'll be left with this A. So A equal to 24 minus 6 minus 12 minus 2, which is 4. Substitute it here. 4 squared is 16. 36 plus 16 is 52. Pi times 52 is 52 pi. Therefore, sum area of cycles equal to 52 pi square units. Thank you for watching. Please subscribe, like, share and comment, and also turn on notifications. Thank you.